Hello, welcome to Advanced Algebra 2. We are in apparently the 11th learning target, although don't worry, we'll go back to most of the others. Mostly, I hope you don't care. Eventually, we're going to be getting into something called logarithms, but for now, we're still trying to work our way around some exponent rules. Just nail these down. The first example here, we're supposed to talk about the third root of 512, the cube root of 512. And there's just some tricks here about what's going on that it's really worth your time to notice. So the cube root of 512, now that's the same thing as the cube root of, and if you break down 512, it's 2 to the 9th power. That's important because now we can use our little property about what roots mean, and instead of calling it cube root, we can call it 2 to the 9th, well, to the 1/3. And as we know, power of a power means the exponents multiply, so it's 2 to the 9 times a third, which is really 2 to the 3rd, which is 8. Oh, so it's 8. And you're likely thinking, hey, but I have a button on my calculator that does that for cube root. Totally true, but this idea about knowing how things break down into their parts, it's why prime numbers are awesome, it's why the numbers work. That's amazing. Anyway, let's move on. Here we have the second example. We have negative 1,000 to the negative 2/3. Same basic idea. A couple key things here, that little tricks that you likely caught up on already, but let's make sure we know. First of all, it's not really negative 1,000 to the negative 2/3. It's the opposite of 1,000 to the negative 2/3, which is why we have the parentheses around the 1,000 to the negative 2/3, leaving the negative out, not feeling included. And so now we can play with the 1,000 to the negative 2/3, because since it's negative exponent, that means it really belongs in the bottom of a fraction with a positive exponent. And so now we can talk about that, and well, 1,000 is really 10 to the 3rd. So it's really 10 to the 3rd to the 2/3 in the bottom of the fraction. And that's just really 10 to the 3 times 2/3, powers of powers and stuff. Notice that negative sign is still sitting out in front waiting for its friends to come back. And so that's really just 10 squared in the denominator. So it's 1 over 100 with that negative in front saying, hey, play with me. So eventually when they get bored of everyone else, the 1 and the 100 do come back and play. So it's really negative 1/100th. Now the third example here, we got a cube root of something divided by a 5th root of something else that looks worse. Okay, so let's see. First of all, I'm rewriting it so we have something to look at and work off of. If you have the cube root of 81 divided by the 5th root of 729, there we go. So 81 is 3 to the 4th. So instead of cube root of 81, it's 3 to the 4th to the 1/3. 729 is 3 to the 6th. So instead of the 5th root of 729, it's 3 to the 6th to the 1/5 power, all in the denominator, because it's on the other side of the divided by. Now, playing fun games with how powers and powers rule, that's really 3 to the 4/3 divided by 3 to the 6/5. And since we're dividing things with the same base, it's really 3 to the 4/3 minus 6/5. And now you can do something where you remember 7th grade and do common denominators, or you can just be like, that's 2/15. And it is. So it's 3 to the 2/15, which really means it's the, 15th root of 3 squared, meaning the 15th root of 9. Oh, good times. 15th root of 9. You never would have, well, maybe you would have. I would never have known that at the beginning. Okay, fourth example. Simplify the expression. Oh, here we have a square root of, a cube root of 60. Okay, we got a square root of a cube root of 64. All right, well, okay. So we have 64 to the 1/3 inside a square root. So it's 64 to the 1/3, all to the 1/2, because it's a square root, It's a little hidden 2 that nobody bothers to write, to the 1/2. Okay. So now we got a 64, and then it's 1/3 times a half because of powers. So it's 64 to the 1/6. Whew, that sounds exciting. Now, if you also remember that 64 is 2 to the 6th, so it's 2 to the 6th to the 1/6. Would you look at that? So, power of powers again. So 2 to the 6th times a 6th, which means 2 to the 1. So 2. Done. Oh, man, that's awesome. Okay, so 512 to the x equal... an equation. We got to solve for x. We're going to have to divide both sides by 500. No, that's not it. Okay, here we go. 512 is 2 to the 9th. So it's really 2 to the 9th to the x. 4 is 2 squared. Oh, check this out. So on the left, it's 2 to the 9x. On the right, it's 2 squared. Those are both powers of 2. That means that we can really just ignore the 2 business downstairs. 9x equals 2, because they're the same base. And so the only way they're actually going to be equal is if the exponents are the same. And so divided by 9, blah, 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 x is 2/9. Done. Okay, so that's it for like fun and games, parlor tricks for powers of exponents and stuff. But we've got some other things to talk about. This scientific notation. I'm getting excited. Excuse me. At the beginning, I have a thing about like, hey, remember what scientific notation is. Please try or at least read these pages. And that's true. And I have a thing about how I really don't want to get in the way of what they're teaching you in STEM Chem, especially, or any other science class, truthfully. So, I'm trying to be glib about I'm afraid of science teachers. I am fairly certain that several of them can take me, specifically Cooper. But anyway, they have chemicals. They win. Okay, so I'm not going to try to talk about accuracy and precision and like when you're dividing things with different sig figs, what you do. I really, really don't care. Here we're just trying to remember how exponent rules play the game with us. So I know in your book you've got some stuff. Ignore all the stuff about precision and accuracy and stuff in the book. I just don't want to get in the way of the important work there. Alright, so now we got a thing here. Notice I reorganized it with the coefficients in front. So we got a 2 and we got a 6 in front, 10 to the 5th, 10 to the negative 3rd. So 2 times 6 is 12. That's, whatever. And so then the exponents add, because they're both powers of 10 multiplying together. And so this makes 12 times 10 to the 2nd. And that's great, but that's not really scientific notation. So to finish, we're going to change it back into scientific notation. 1.2 times 10 to the 3rd. Now, a thing here. It was 12, and it went down to 1.2. So it lost a power of 10 in the number part in front. So that means that the power part gains a power of 10, which is why the power part went from 2 to 3. Another way of looking at it is 12 times 10 squared is 12 with 2 zeros on the end, but that's the same thing as 1.2 with 3 positive direction movements for you. Okay, next one, but this one's about dividing. So here we're talking about some dividing. So let's see, here we got a 2, 6, so that's 0.33 bar. 10 to the 5th, that would be a minus -3 because you're dividing, so you subtract the exponents. All right, and then we got 0.33 bar. Oops, I forgot to write the bar. Sorry. That's times 10 to the 8th. So then it's 3.3 times 10 to the 7th because we made the number part look bigger, so the exponent part needs to look smaller. And I did mention slightly I forgot the bar, so let's make it all correct exactly. There we go. So notice that we need to fix our answers sometimes to put them back in scientific notation. I notice that both examples 6 and 7, the directions didn't tell you to put your answer in scientific notation. I'll try to not continue to make that mistake. I'll try to always be sure to tell you to put it in scientific notation. But hey, we got example 6 and 7. Little business about scientific notation, nothing terribly exciting. And we got the first 5 examples, slightly different versions of crazy tricks I can play on you. Here's an assignment. If you want to start it, it's great. Knock yourself out. If you want to wait till class, that's also okay. The benefit of starting is that if there's something that seems a little off to you in the notes, you can see whether or not your sense is right. And then if you start and you don't get anywhere, then you can come ready with questions going, ah! If you don't start, then you'll just discover in class whether or not you're feeling blah. Hey, anyway, thank you for watching, and let me know if you have any questions.